let us see what is meant by orthogonal vectors. Two vectors are given, A vector and B vector. If vectors are orthogonal, these vectors will be perpendicular. If vectors are perpendicular, dot product should be 0. To check whether vectors are orthogonal or not, you have to take the dot product. Now let us take the dot product of these two vectors, A vector dot B vector. A vector is 2i plus 3j, then B vector is 4i minus 5j. I dot I is 1, so 2 into 4, 8. I dot j is 0. Next, this with this, j dot I is also 0. Now, j dot j is 1. So, 3 into minus 5 is minus 15. 8 minus 15 is minus 7. So, it is not equal to 0. Dot product is not equal to 0. So, vectors are not orthogonal. Meaning is, they are not perpendicular. If vectors are perpendicular, dot product should be 0. Now dot product is not equal to 0. Now let us see another example. C vector and D vector. Now take the dot product. C vector dot D vector. C vector is 5i plus 2j. D vector is 2i minus 5j. I dot I is 1. 5 into 2, 10. Next, this with this. 2 into minus 5 minus 10, j dot j is 1. So 10 minus 10, 0. So you are getting 0. Dot product is 0. That means vectors are perpendicular. When vectors are perpendicular, it is known as orthogonal. So the C and D are orthogonal vectors. A and B are not orthogonal. Two vectors are given. A vector is 2i plus 4j plus 5k. B vector is I plus 3j plus 6k. We have to find the dot product or scalar product and the angle between these two vectors. A vector dot B vector. A vector is 2i plus 4j plus 5k. B vector is I plus 3j plus 6k. When you take a dot product, I dot I is 1. 2 into 1, 2. But I dot j will be 0. Then I dot k also will be 0. Next, this with this. J dot j is 1. 4 into 3, 12. This with this will be 0 because the j dot I is 0 because angle between I vector and j vector is 90. When vectors are perpendicular, dot product will be 0. Next, this with this 5 into 6, 30. K dot k is 1. When you add, you will get 44. So A vector dot B vector is 44. A is a vector, B is a vector. But A vector dot B vector is a number. It's a scalar quantity. So dot product is a scalar quantity. Next, modulus or magnitude of A vector is square root of 2 square plus 4 square plus 5 square. That is root 45. Modulus of B vector, that is square root of 1 square plus 3 square plus 6 square. That is 46. Then angle between the vectors is given by this formula. Theta is equal to cos inverse A vector dot B vector divided by modulus of A modulus of B. A vector dot B vector is 44. Modulus of A vector is root 45. Modulus of B vector is square root of 46. So if you do this calculation, you will get 0.967. From natural cosine table, you can get the angle. So cos inverse 0.967 is 15 degree. So angle between the vectors is 15 degree. In physics, work is the dot product of force and displacement. So work is a scalar quantity. Force and displacement both are vector quantities. So dot product of two vector quantities will be a scalar. So work is a scalar quantity. F vector dot dr is F dr cos theta. F is the magnitude of force. Dr is the magnitude of this vector. So W is equal to F dr cos theta. Now let us see some special cases. Suppose the force and displacement both are in the same direction, then theta will be 0. Theta is 0, cos 0 is 1. Cos 0 is 1, so work done is F into dr. Force you have to multiply by the displacement when both are in the same direction. If force is in some other direction, so we have to multiply the component of the force in the direction of the displacement. This is the direction of the displacement. So F cos theta, this is F. So this will be F cos theta. So dr we are multiplying by F cos theta. Suppose the angle between the force and displacement is 90 degree. Cos 90 is 0, so work done will be 0. Suppose the 180 degree, theta is 180 degree. Cos 180 is minus 1, so work done will be negative. Now, I hope you have understood. Thank you for watching.